Hey, I don't know if you hear me. Hello, this is Mr. Columbia Backpack, and I'm going to show you something interesting. And I hope it's going to be interesting. Yeah, I hope my phone will allow me to like last this video till the end because it's always lack of memory. I store so many videos there, so sorry if it just breaks. I I I cannot yet find time to clean it. Yeah, let's go. This is Mr. Columbia backpack. Yeah, let me put it. Oh, sorry. Yeah, this is Columbia backpack, and this backpack has changed my life. Yeah, it just changed my life, and I'm going to explain to you why. Yeah, this still works. I don't know if it will last for enough, but let me be fast. Here it is. This backpack of my notes. After 2 years of studying math, it is quintessence and the essence of all what I studied. Those are just conclusions and summarization of those big books and a lot of stuff which I have taken during this time. So yeah, I study in Russian, and this is just the probability theory, small book, and statistics. Yeah, and this one is just small, but it covers all possible things which you might need. Yeah, and that's kind of cool, and it has all what you need. I mean, in summarization, it seems to be small, but it's kind of what's tricky about this book. It's just short and enough for like basic engineer. If you have no background with probability and statistics, it just gives all what you need, but it's kind of more theory. Yeah, there are no practice. It's just summarization of theory. Yeah, you just go for it if you need some, if you just solved a lot of problems and then you go back to like review everything. And yeah, there is something else involved. Yeah, I don't want to break the sequence order. And yeah, this was control theory, right? I hope. Yeah, that's control theory, and it's kind of crazy. It's more for practice. Yeah, it's one of the. I just started this notebook, but I haven't finished it. It was the craziest subject I ever taken, the control system theory, because I didn't know electronics. I didn't know those like frequency control, what it needed, what it's needed for. I haven't even understood how it's related to differential equations at this moment. What only proves that you not necessarily need to like know the reasoning behind before you start, because that just happened. It hasn't happened on purpose. I just didn't know how to relate it to the real differential equations at the moment, because it wasn't mentioned at my book, which I was giving at the university. But then I figured it out. So yeah, and anything else? Yeah, that's also control system theory. It's just kind of practice. Say, it's probably practice, and I just will show you one of them, so you just get an idea what I was doing. Yeah, and that's just, you go for Nyquist diagrams and Phasor diagrams somehow, and then yeah, differential equations. They're like, this is a convolution. I remember it. I was trying to explain to myself the convolution in the meaning of how it's giving in how it's connected to the math formalization, because the hardest is to get what exactly how this formalization maps on the real world and the real imagination. And that was cool. Yeah, solving linear equations by that. Yeah, kind of my drawings during this way. That's cool. My drawings are always with me. Yeah, just giving it back. Yeah, I'm constantly checking if my phone allows me to. I have something like 2 GB free, so I hope it works. Yeah, and then you go for, yeah, that's also control theory. It's more of a main concept. Oh, sorry, main conspectus. Yeah, with just a sec. Just like, yeah, that's kind of, you go there. Yeah, I remember it. I was trying to understand how it maps to differential equations exactly, and that, yeah, and it's amazing. Yeah, this Nyquist diagram again, the phase margin we have, and yeah, all that kind of summarization, how you move blocks in those control systems, diagram notations, and yeah, that was cool. I don't know if that works for you. That works for me. Yeah, kind of. Okay, let's go then. We go to, yeah. That's one is theory of information. Yeah, how signals transferred and what's happening with them. There are a lot of stuff there. Again, somehow the probability, it's here. Yeah, some discrete math. And then you go, yeah, differential entropy of the emitter, I guess. Yeah. Oh my goodness. And then you go for, yeah, that was probability, solid probability. Check this out. Yeah, I remember this equation. I wasn't able to solve it, and then I solved it. Yeah, that was something like logarithmic function. Yeah, there was exponent under the integral, and that's what needed for, yeah, I was trying to solve something like exponential distribution and get out the formula of it. Yeah, that was cool. Oh, all like probability all together with information theory. I don't know why. Yeah, that was kind of practice. That's not that much here, because what I usually do is something like that. Those are my papers, and everything else is just summarization. It actually was an experiment trying to write it in notebooks. I usually never do it. I use solid papers and then summarize it somehow. And that was cool. I couldn't say I remember everything, but it always, like, if you need to come back, for somehow this skill sticks with you, and I think it's cool, yeah, to have it with you. Yeah, let it get back. So how I cannot break the order, I guess I will do something like that. Okay, so this is, what even is that? Yeah, finding the trust interval, or whatever it's called in English. Yeah, that's statistics. Yeah, those my small conspectors on statistics. Why is that small? Probably, yeah, the quintessence of it is not that big. Yeah, I don't know. Yeah, and then how I think it should be probability. Yeah, here is that probability. Yeah, that's one kind of bigger. Yeah, that's one kind of massive. Yeah, if you can see that, that's amazing. Poisson distribution, binomial distribution, geometrical distribution, hyperbolic distribution, yeah, all that stuff. Yeah, it's kind of funny. Yeah, local and integral theorem of Laplace. Yeah, Bayes formula. Yeah, yeah, it's kind of vice versa. You know, I start usually from there. That's the page 1 usually, and then you go. Yeah, it's even -1 page. I mark it as -1. It's combinatorics. It's like prerequisites for probability theory. Yeah, and that's page 0, and yeah, and that's is page 1. It's actually all the probability in one page. Like, I mean, basic course, of course. It's like basic course of probability in one page. Yeah, the types of how do you call it in English? I don't remember. Like, so yeah, they're just beautiful, and then I just like to make them beautiful because that's exactly how you learn. I mean, if you make beautiful conspects, that's the way how you treat the information you're given. Like, while you're writing it by your hand, you like give your brain time to process it, and of course you solve a lot of problems, but you kind of have to give yourself time to process it, and it's just cool. Yeah, that is. Then machine learning theory, thanks for Andrew Ng. I just started it, and I understood that I'm not prepared yet for this. That was only one lesson I have taken. I made this notebook for taking the whole course, but then I realized that I'm just not prepared for this, because as you see, it was just time I was starting statistics and probability theory, somehow a year and a half ago. And that's what that one? That was statistics. Okay, I haven't even write anything there. I just give it a place, but didn't even feel it. Yeah, that was practice note. Yeah, that's crazy. I don't know what's even happening here. I was solving it. It's crazy. The guy was literally on the other planet. What's going on here? That's crazy. I remember myself lost on those pages. Yeah, that's what statistics. Yeah. It all have taken all my time just to solve problems. I didn't even summarize anything really. Probably, yeah. That was just the moment I understood statistics. Like, basic course of statistics is it's so simple, I'd say. Yeah, basic statistics course is so simple. You just have several formulas, and then you just solve problems, and then you just like it stick with you very easily. I do think it's even should be giving at school, but yeah, a lot of integrals here. I'm not sure if it's appropriate for people. Yeah, it's just the way it's giving. Yeah, oh my goodness, that was cool. I remember it actually. Yeah. Next one. That's... What is that? It's strange. I don't understand what is it. I don't remember it. Okay. Oh my goodness. Oh my goodness, guys. It's a legend. It's optimization theory. Yeah, the kind of page one. Yeah, of course. It starts from the back. And then, yeah. Simplex method. I just summarize it, how it's done in 6 steps, just to remember how to solve it. Yeah, it's definitely, yeah. It's linear programming first. That's a map of what we're going to study. Yeah. Those are problems without I mean, wait a second. Yeah, there were like topics as problems with constraints and without constraints, linear and non-linear. And yeah, that too much time it took for me to understand how linear programming works. It moved like algorithmic steps. It's not like that they don't make that much of a sense at the moment. Don't know how people just let it be the way it is. I haven't understood how you actually come to those methods and why they works, but they works. Even at tree method, yeah, I remember the tree method. Yeah, there's so many different approach for optimization problems. Oh, sorry, you haven't seen it. Yeah, there's so many possibilities to solve different optimization problems. Depends on what objective function you have. Yeah, that's crazy. Yeah, the linearization method at nonlinear problems. Yeah, that was crazy. Yeah, I like it. Yeah, where's non-linear part? I'm interested. Okay. Yeah, that was kind of graphs theory. I don't know. I think this course pretty varies from the university to university and from program to program. But you start with basic, like you just study formalization here. You just don't study that much of a problems. That was solid theoretical course on how to talk about those things, how they can be distributed, what the different types of distributions depends on how they all connected, and if they have any orientation in connections or how they can be solved. It's then used in control theory. Yeah, and yeah, the different approaches to describe the graphs and so on. And here is that discrete math. Yeah, where that's the ways they're like basic Boolean functions. Yeah, that's crazy. The different approaches to solve, to simplify the Boolean expressions. I like the method when you solve it by the cube. Yeah, I don't remember everything in details, of course, which is kind of not that cool, but yeah, I think if I will spend time, we'll get those things back to my head. But those are cool, yeah. And then you go for, what is that, guys? What is that, guys? Let me check. Oh my goodness, that's my laugh. That's my laugh. Yeah, that was kind of, What's going on there? Yeah, there was special math functions. Everything is here. Everything is here. Eigenvalues. Yeah, different definition of summation and multiplication depends on different groups of mathematical subjects. It's more abstract theory. Yeah, and everything involved in that course. Eigenvalues, functional analysis. Yeah, but only basics. It's not like of course it's impossible to cover everything, but like you basically develop your abstract understanding of the theory, and you develop the structure of the science and how you go. Bessel function, yeah, that was crazy. There was a recurrent function. Oh my goodness, Gaussian function. Yeah, those ones are crazy. Yeah, Bessel functions. Yeah, something about complex numbers and residuals, or how you call them. I'm not sure how they called in English, honestly. Those residuals. I don't know. I probably talk shit, but okay. And yeah, those are complex transformations into a complex plane. Yeah. And those were useful later on in controls also. Yeah, now I understand it's all can be like explained much faster if there would be a nice teacher with me, but I was learning all on my own, and I was just writing everything down until I understand what's useful, what's not. In spoiler, everything is useful. Yeah, Fourier series and Fourier transformation and Fourier integrals, and yeah, that was cool course. Wasn't that hard, honestly, but I mean, no, of course it was hard, but there was only basics of everything you need, and it was cool. And now my favorite, those are like my lovely ones. Those are the best. Everything have started there, and this story is like when I remember those days, I kind of want to cry. There was the amount of information I actually can proceed in math. My brain was so small at that moment. I mean, in terms of mathematical notations and parsing them, there was analytical geometry, you know. There was analytical geometry and math analysis, basic calculus, I mean. Yeah, and those are just summarizations of the material and a bit small practice. Yeah. And then what else we have here? Yeah, that one is my favorite. It's probably calculus 2. I don't know what you guys called it as, but or even calculus, just calculus. There's so many. Yeah, look at this guy. Look at this guy. Yeah, he's funny. Yeah, those. Yeah, basic tables of trigonometry, and they were used a lot. Honestly, I still hate trigonometry and the integral table, which I was actually shaking because that's one already dying, and that was dying at that moment, not because I hold it here for several years, no, but because that's supposed to die in the first place. Honestly, yeah. Different useful functions in trigonometry. Yeah. Yeah, getting back. Yeah. That was already multivariable calculus. and limits and everything. I remember that was like a pretty solid, a pretty solid stream of information into my mind. And yeah, how you go from any function to Fourier series, and how you can calculate any solution by just series. And yeah, that way I understood that series is super powerful. Yeah, those differential equations, I remember that was like this differential equation summarization, all the differential equation course with all the solution have taken me half A4 paper, and that was useful on the exam. I don't remember, I had a possibility to check my conspect once, and I just came there, and I remember something was written there and somewhere else. It didn't really help, but this, I think, which gave me so many confidence at the moment, because I could just check there and I have everything what I learned mapped on this small paper. Yeah, that was one of the best conspectus I ever made, and probably the first one, the most loved one. It's so simple, it's so like, it just everything written, like only what you need. If you can't solve some problem and you're trying to solve some problem, you can just take this conspectus and everything is here. Yeah, that was crazy. I started it 3 years ago, and there only 2 years, because for the last year I'm doing another thing. And let's check what's going on here. I have no idea what is it. And oh my goodness. What I was trying to, those are electrical components, and I actually hated this course because there were nothing to practice with, and I had no idea with basic electronics, and all that was kind of crazy. Eberson model, and that was crazy. I don't remember anything from here, to be honest. NP, and like all the different types of transistors, and yeah. At the moment, I didn't even understand why do you use differentials in electrical circuits. Why do you need it? And that was crazy course, and I don't remember anything from here, but all that what I studied, this is literally 2 years. This is literally 2 years of my life, and I'm really thankful to God that it was given to me, because I was lost in those pages, like in the forest. That was amazing, and I'm really thankful to everything on that earth what pointed me to study this, because it really gave me happiness, because my main goal was always to understand things and understand the math formalization. And that was my goal for the university, because if you open any scientific research or you're interested in something, you can't even read it because you don't understand the math notation and the structure of scientific readings. And that's like so important for me. I don't know, this thing has changed my life. And while all this were happening, I was working full time, and I just needed to come home at evening and spend time with those things. And I don't know, I want to repeat it. If I could repeat it and try to leave it some number of times again, I would make it probably at least 10 times, if not endlessly. No, I couldn't say endlessly, no, of course. I was doing it for some goal to move on the next step, but that's so hard and you don't feel belonging to it, but then you do it, and at the moment you feel relief, of course, and at the same time it's a bit scary to go to the open world, because everything here is pretty defined, and you have like books which teach you how to do all that things, and nobody in the real world usually show you an actual and the right solution, and you not always sure about the things, and you need to kind of, you don't know at the end of the day. And yeah, that was amazing. And of course with it I had so many things else. There are many concepts, but those are essential for me and important, because I knew without math I couldn't move further in the life for some reason. I don't know, just scientific desire to know it. I'm just a usual guy. Like my university is none of anyhow close to be any even top of 10,000 in the world. But all that I just did on my own, and I don't know, it gives me so much freedom and power now in better intentions in the mind, of course. It's so cool. I can't even recommend it to everybody. I can't tell you like, bro, you need math if you need it, but believe me or not, it's like watching a really beautiful film. Yeah, it's like the most interesting movie you could ever find. Yeah, and it's like movie which is written by you. You write this story by yourself, and at the same time you're watching it. And yeah, I can't tell you. It's just simple equations, simple numbers, simple, but at the end of the day, it feels like nothing has happened. I feel almost the same person, but it definitely changed something in you, and it probably gives you self-confidence and self-belief that you can do hard things, and it's the most important part about it. Like, yeah. And I'm not really about the physics. I was doing physics the whole school. And then when the university came after the school, I went to the university, and I was scared of physics, because it was physics with calculus. I didn't understand it, and I couldn't study math either, because I just didn't know how to study in general. Yeah. And then I dropped out, and then I returned after 5 years back to the university at the age of 22. And yeah, I was turning 22, and I came to study math in order to understand physics later. And yeah, you just understand it automatically. I studied physics at school, so you look at those formulas, just like, yeah, now I see what it is. Now I understand. It's more just generalized view on things. That's cool. And yeah, I don't know, like, it's only 2 years, but it feels like inside of it, like I'm living not just one life, I'm living through 10 lives. And of course, because people who Joseph Fourier, Laplace, and Newton, and all those people, those geniuses, they were investing their lives into these works which you can study and understand. And it's like, yeah, this literally feels that I lived not just my life, I lived through several lives of those people who were making it up, who were making it. And of course there are a lot to explore. Math is endless, but it's just something what you can take from the university, and you can thank God that it's given to you, because nothing can be given to you in this world except some knowledge, and you have nothing except your knowledge, in a fact. Yeah, you own nothing. All what you truly have is the knowledge. If you ever move to another country, you know it, that since you moved, you understand that you have nothing more, even not your language. And all what you have is like the knowledge which you bring with you, and understanding of the world. And yeah, doesn't matter where you are, if you in Germany, in Australia, anywhere, those things will stick with you forever, probably forever. And I find it's cool. Yeah, even you're 70 years old, it's still with you, and it's something you add to your brain forever. And I think it's beautiful to add something forever, something not negotiable. Yeah, and you can, it's not making your life harder, it simplifies it. Math simplifies things. Yeah, that's the biggest thing to feel while you're doing this, that it simplifies things, actually. Yeah, that's crazy. Thank you very much. I'm so happy I can share it with people. Yeah, probably I will share something else about my journey in the future. Thank you.